Welcome back, everybody. This is our video solution to problem 3 from quiz 8, spring 2023, Math 302 at Cal State Fullerton, and we are back talking about equivalence relations again. So in this problem, let's see, we say let f, and that's a neat looking f, right? Let's see. Oh, yeah, there's a pretty looking f. Okay, it's going to denote the set of all functions from the unit interval 0 to 1 to the set of real numbers. Okay, so if we were going to take an element f in curly f would be a function whose domain is the unit interval and whose codomain is the real numbers. All right, and it says we're going to define an equivalence relation, looks like it's called R, on f in the following way. If I have two functions, right, from 0, 1 to R, then they're going to be related. Okay, so remember, of course, if I have an equivalence relation, or any relation, it's going to be a subset of the Cartesian product of this underlying set, right? So if it goes from f to f, then this relation is a subset of f cross f. So I take two elements from f, and I want to know when they're related, right? When they're going to be, this pair is going to be an R, and it's exactly when f of 0 is equal to g of 0. So they have the same value when you put 0 into the function. And there's a little parenthetical here telling us we can assume that R is an equivalence relation. You should not prove it. Hopefully on the quiz you read that and you didn't spend your time trying to prove that R is an equivalence relation. All right, now let's go to the first problem. It says we want to describe all elements of the equivalence class of, oh my goodness, what a function, 5 to the x plus x minus 1 squared plus 4. Okay, now it is very important to recognize the definition of an equivalence class, right? So the equivalence class of this element, 5 to the x plus x minus 1 squared plus 4, okay, this is a function whose domain could be taken to be 0, 1. It spits out real numbers. So the equivalence class is going to be all of the functions that have the same value at 0 as this function. So let's write that down. So the equivalence class, and I'll use the square brackets for that, the equivalence class of 5 to the x plus the square of x minus 1 plus 4 is going to equal the set of all functions in f such that f of 0 is the same as this function at 0. So this is going to be 5 to the 0 plus 0 minus 1 squared plus 4. And we can simplify this, okay? So 5 to the 0 is 1. 0 minus 1 is negative 1. Square it, that's also 1. All right, 1 plus 1 plus 4 is 6. Okay, so there we go. If we wanted, we could rewrite it a little differently. We could say, okay, this is going to be all functions from 0, 1 to r such that f of 0 equals 6. Okay, and that's the best we can do, right? Like, there's not a really amazing way of classifying all functions whose value at 0 is 6, so that's about where we have to stop. Okay, so this will be the equivalence class of that function. Okay, things a lot of people will do is they'll evaluate maybe this at 0 and get 6, and they'll say, okay, so 6 is the equivalence class. I mean, there's a lot of mistakes you can make here, right? All of those mistakes go away, though, if you just go to the definition of equivalence class, right? All right, let's go to B. B says to find an R transversal of F. Okay, well, that's important to know what that means, okay? What do I mean by an R transversal? Well, R is the equivalence relation. A transversal is going to give me one single element in every possible equivalence class. Oh my goodness. Well, how many equivalence classes are there? Well, we know that two functions are going to be equivalent if their value at 0 is the same. If they're not the same, then they're not equivalent. How many different values could I get at 0? And the answer is, well, okay, what if I just took like constant functions even? Constant functions at 0, there's an infinite number of them, right? I could put 0 in and get out any real number. But that there is the key. Once I know what the value is at 0, it doesn't matter what the rest of the function does. So I can just choose some function that I know that's going to spit out every single value. And again, I'll just take the constant functions. So a transversal, right, or an R transversal of F is the set of all constant functions with domain 0, 1 and codomain R. Okay, so if I wanted to write that out explicitly, I could say, okay, let's look at, let's see, so if it's a constant function, then maybe I'll use a C for constant. And now I need to tell you what that constant output is. Okay, it's an arbitrary real number. Let's call it alpha. Okay, so C alpha goes from 0, 1 to R. And what's it going to do? It's going to evaluate at any x and just return alpha. Okay, and we're going to look at the set of that as alpha runs through all elements of R. So that would be a transversal, right? Just all constant functions. Okay, now in part C, we're asked to use our answer to part B to describe the quotient set. So the quotient set is the set of all equivalence classes. It's the set of all equivalence classes. Now, one way that I can do this, right, is I can say, well, okay, I know that as soon as I know what the value of the function is at 0, then I know every function at equivalence class, right? I know what it's going to do at least at 0. All right. So that's all I actually have to talk about, which is why, of course, these constant functions worked. So when I go to write down my quotient set, this is going to be, again, the set of all equivalence classes, or of all R equivalence classes. And I can just use these constant functions as my representatives. So I could take the set of all of these C alphas, right, the equivalence class of all these C alphas, as alpha runs through all the real numbers. Each one of these C alphas gives me a different equivalence class. And so this would be the quotient set, right? It's at least one way to write it down. And what you might notice here is that it essentially looks like the real numbers. Yeah, okay, this doesn't look at all like the real numbers, but you get one for every real number, right? And that's it, right? There's this nice bijection. Okay, so there's a bijection with the real numbers. You give me a real number, I'll give you one of these equivalence classes. You give me one of these equivalence classes, okay, I'll just evaluate the representative at 0, and that gives me a real number. So there we go. All right, so good chance a lot of you still going to be struggling with this one, right? It's subtle, right? It's going to take some work, but keep watching these things, keep practicing, try to make up your own versions of this. Just always focus on this second half, which is, right, like, yes, I know it's good. You need to show something is an equivalence relation, but it's not enough. You need to understand this incredibly big idea of quotient sets and transversals. All right, well, we will see you next time, everybody.